All right, we're going to get started. So good morning, everyone, or I guess good morning where I'm sitting. I think for where most of you are sitting, it's probably a good. So thanks for joining me at the end of the day here. This is navigating microservices with .NET Core and Thai. So if you're here for a different talk, you're in the wrong room. So physically get up and move yourself to another room. Just kidding. So we'll get started. So a little bit about me. I've worked on ASP.NET Core for many years as architect and developer. MVC, routing, client factory, health checks, Razor, Blazor, and something new called Project Thai, which we'll be talking about in quite a lot of detail today. Um, and so that's normally how I would introduce myself, except as of about a month ago, I'm part of the Azure Incubations team. So this is probably my last conference talk ever representing the .NET Core team, which is a sort of a bittersweet end and a bittersweet farewell. But it's been an awesome journey doing .NET Core and ASP.NET Core, and I'll always hold that in my heart. So what are we going to do today? We're going to talk about your developer productivity. And specifically, I'm speaking to developer productivity for you building services, building backends, building microservices. And I don't really care if you like to use the term microservices to describe what you're doing. I don't think it matters that much if you feel like you're really doing microservices or you're just building modern backend and modern web sorts of applications. The truth is that really, like every application is a multi-tier application. Every application these days has got multiple components to it and multiple layers to it. And it's very rare that we're actually building applications that are just one component these days. If you're there, like you're lucky because you're developing your development process is probably pretty simple. So we're going to talk about how to accelerate your productivity with the focus being on a new tool that we're building called Anatai, and how you can become more productive and more successful by trying to make development more like production. And we'll show how you can easily containerize and deploy .NET Core services. So a little bit about .NET Thai. We're going to jump in with a lot of demos, by the way, pretty much right away. So a little bit about .NET Thai. What we're referring to as a public experiment for .NET 5. We'll talk a little bit about what that means, but it basically means that we're building, creating, and innovating on a tool in the open on GitHub with the community that sort of has an unclear destination. We're just trying to build some cool tech. We're trying to learn as much as we can along the way. And we'll talk a little bit more about what that means in the future. And it's a .NET Core focused cloud development tool, focusing probably on your local development, but also a little bit on sort of deployment, publishing, and your overall microservices workflow. And if you haven't checked it out already, you can find it on GitHub. Hopefully, what you're going to see today is going to wet your whistle a little bit and make you interested to go look at that and tell us what you think. So with that, I'm gonna drop down of the slides, new personal best of 3 minutes of slides, and we're just gonna go right into some demos here. So I've got my terminal here, and I'm gonna load up the first demo. And where better to start with demos than a sort of hello world kind of application? Really simple little thing. And we're really going to get to the essence here of what it means to do microservices development or to do multi-service development. So I've got a front-end project and I've got a back-end project and I've got a .NET, I've got them in a .NET solution here. I'm using VS Code, by the way, if you haven't figured that out. And I'll just show you all the code in these projects. There's a really small amount of code here, and there's absolutely nothing tricky going on. So here's a front end project. It's got no dependencies other than ASP.NET Core. And here's my back end project. It's got no dependencies other than ASP.NET Core. And it's got a program CS and it's got a startup CS and configuration. And other than that, there is nothing going on. So let's take a look at the code. And I'm trying to build basically the simplest thing that gets to the essence of what you're doing if you're doing microservices over HTTP or just, web app and API tier style development. So I've got the standard boilerplate startup CS. I've got JSON serializer options, and I've got one little endpoint here, and I'm just going to respond to the root URL. and I'm going to respond with some information about myself. So what is my local IP address? What is my local host name? And what is my content type? And serialize the JSON to the response. That's the backend app. And my front end app, we'll take a look there. And in my front end app, I've got health checks, and I've got one endpoint here. I'm going to respond to the root URL, and I'm going to do some service to service communication. So I'm going to do sort of the first most basic thing here. I'm going to get an HTTP client, and I'm going to call into my backend API. And I've got a little helper method here to get the URI of the backend service. And then I'll deserialize the JSON, and I'm going to print out basically the same information for myself. So where is my backend IP address? What is my backend host name? So just demonstrating really that I can communicate between these two services. So we're really doing fundamentals here, but if I wanted to run these two projects, like what would I do? Think about what you would do if you'd run these projects. If you're in VS Code, you might open two terminals and launch two projects at two terminals. I have heard legend tell that it's possible to write a launch config for VS Code that will launch them in both at the same time. Some people I know would open like two VS Code windows. The other thing that you could do if you're in Visual Studio is that you could use Visual Studio to configure a multi-project launch, which is kind of hidden in the menus, but it seems to work pretty well, and you can get an experience where you launch multiple projects. But I guess what I want to impress upon you is that most of our solutions, most of our tools and technologies that we use today are really oriented around the idea of running one thing at a time. But when we do microservices development, or we do multi-service development in general, we're really talking about running multiple things at a time. The other thing that I would mention is if I'm doing this in VS Code, I will get a port conflict in VS Code by default. By default, these services are both going to want to use port 5000, and that's going to conflict in VS Code, and it's going to cause a problem. Now, in Visual Studio, by default, again, you would get different ports because IIS would use different ports by default. But maybe you're not using Visual Studio. Maybe you're not even on Windows. Maybe you're not using IIS in production, and so you're not using IIS as part of your development. All these factors come into play, and you have to play this game of how do I choose ports that I can remember that don't conflict with each other so that I can launch my apps at the same time and everything can work in harmony. So we're now to the first thing that Ty can do for you, and let's go ahead and run some code. Sorry, my prompt is taking over the world. So we'll do a Ty run, and I'm in the same directory as my front-end back-end solution. And so over here we can see loads application details, launches Ty host, runs a dashboard, builds projects, and then there's a whole bunch of spew, which you can probably ignore. If I click that link, that's this link right here. It's the Ty dashboard. The dashboard is always going to launch on a predictable port. And what I can see when I come to the dashboard right away is, well, it's got a list of services. It's got my front end, my back end, where they came from, what URLs they're listening on, replicas, restarts, and logs. So it's pretty cool. So this is like, you should sort of think of this like your developer console for multi-service development. You need a sort of status dashboard, or sort of like, here's the state of what's going on. Let's go ahead and try this. Let's try my backend service and see if that's working. So I'll just open that URL, and you can see that we got a response from the backend service. This is my host name where I'm sat. And then let's try the front end project. And so the front end project is crashing because the request URI must be an absolute URI, or base address must be set. I've done a lot with HTTP client, but I'm not really sure what that means. So I think what I want to do is debug. And so I'm going to come back over here, and I'm going to do Ty run again, but this time I'm going to say debug, and I'm going to add front end. This is confusing me, front end there. So now what it's going to do is it's going to do Ty run again, and it's going to launch the processes, but it's going to halt the front end process from starting. So if we did open the dashboard and we did try to visit this app via its HTTP URL, it would just block effectively, because we've injected code into the process that's going to trigger basically a wait loop, and it's just going to wait for a debugger to attach. So this is a nice way to be able to get your startup errors and things like that when you're doing a multi-process launch, which is a nice little convenience. So if I come over here and I say attach, you can see I've got my backend and front end processes running. If I choose front end, it's going to tell me everything about all the symbols in every DLL that's ever existed. Thanks. And I'm right here at my get backend URI call. Let's make sure that that's working. Oh, it's null. Okay, so that's the problem. So I'm not getting the URI of my backend, and I know I lied to you. I tricked you. That was mean. I said that we would be able to get the URI of the backend, but we can't actually do it. Let's take a look at the implementation of this function. Yeah, sorry, I've got a to-do here that I didn't quite address, and somebody let that through code review. So we need to now know, if we're going to do service-to-service communication, we now need to know how we're going to get the URI of that other service. And it's not really as straightforward as it sounds, because maybe the URI of your other service is going to be different in development from production, from staging, from your machine, from the way your friend likes to debug, and it could be different, right? It could be subtle, and there could be lots of complexity to it. So I have a sort of thought in my brain that as a developer or as an engineer, we like to solve problems, and we like to build conventions and solutions about how to solve problems. So one of the things that I might do, or I think that you might do if you needed to solve this problem, is you might say, well, I'll use environment variables. I'll use environment variables to pass in the host name and the port and the protocol and things like that. And then I can build a URL from those things. Or you might choose to use an environment variable to pass it all in one. So I'm going to take a stab at that. So let's say I use some environment variables here, and I'm going to read these environment variables, and I'm going to combine them into a URI, and then I'll log the result. So let's give this a try. Try run again. Let's bring up our dashboard. So everything seems to have started. Everything seems to have been working. Let's give this a try. And it worked. So we got the front end and the listening IP. We got the host name of ourselves. We got the listening IP and host name of the backend. And they're the same, but the fact that I can print this out proves that I actually did call through to the backend and get that information. If we come to the dashboard and look at the logs, you can see that we've actually logged the backend URL. So we did get the backend URL and environment variables, and we did feed it out into these logs. So that's working, but this is still kind of grunge compared to what I'd really like to do. So, if we're ASP.NET developers, one of the things that we have that's really nice is configuration, right? A bunch of different sources of data feed into configuration, including environment variables by default. Could be JSON files, could be environment variables, could be command line flags, could be lots of things. It's extensible. So can we leverage configuration to do the same thing? And spoilers, yes. So the reason why I chose these particular environment variables is that these particular environment variables map to some configuration keys. So it's not a mistake, not a typo, double underscore for kind of bizarre reasons that you can ask me about later if you want, maps the configuration key separator. So if I wanted to, I could replace that with this. And so I could say, get the service node from configuration, get the backend node from configuration, and get the protocol node from configuration. And that's like if this, it's like if I used this configuration style and so on, right? Those separators, those colons there represent a nested configuration structure like you would see in JSON. So if you were code reviewing this, I hope you would say this if you're code reviewing this. Maybe you would, maybe you wouldn't. But if you're code reviewing this, you might say, that's kind of messy. And it really seems like this code could be extracted into a library or into a helper method so that we don't end up with 50 different versions of this code copy pasted. Really, the only thing you care about is this. And if you got a lot of services and you got a lot of different touch points of communication, you're going to have a lot of versions of this code copy pasted around, right? So let's do that. Let's write a little helper method for it. And I will tell you that we have written that helper method for you. And the reason why it's not showing up is that we've shipped it in a NuGet package. So if I come over here to my project file, I can add this package, Microsoft TIE extensions configuration, save. And then any moment now, there we go. We store and we should be okay. Yeah, good job, VS Code. So let me jump to this, and I will tell you that this is basically the code. This is basically the code that is in that block that I showed you before. And this is like the world's smallest NuGet library. It's not literally the world's smallest, but you get what I. It's got one type and it's got two methods in it. And we've got an overload of get service URI, and we've got an additional overload of get connection string. And these are all TIE's opinions about how to get data from one service to another. We call this service discovery. TIE's opinions about how to do service discovery are that we set environment variables. Those environment variables follow a predictable convention, and those environment variables can flow into configuration so that you can query them using anything that has access to configuration, which is pretty cool. And there's no trickery. This looks like and really sort of feels like to me a convention that somebody else would design. So if you decide you don't want to do it this way, you could do something different, but having a built-in convention helps us and makes us really productive. So if we walk through what we've seen, the fact that we have these two projects in the same solution means that TIE will generate environment variables when it runs them, inject them into each process so that the processes can know how to find each other. Those environment variables get read into configuration using the built-in sort of defaults of ASP.NET Core configuration. And then you can use this helper method to query them. But at the end of the day, it's just environment variables and configuration. There's nothing really tricky or magical happening here. It's just because they're all part of the same thing. So let's see something else that's kind of interesting about. And that's the question of like, well, I said, let's make development like production. One of the ways that we can help make development like production is giving you access to your production tools in development and giving you patterns that encourage flexibility so that you can leverage all that. So one thing I want to highlight that I think I forgot to highlight before is if we look at the dashboard, you can see that these ports are auto-assigned, right? These are you'll notice that they're sequential. You won't find these hard-coded anywhere in the code. TIE is assigning these ports and handing them off to ASP.NET and saying, hey, please use these ports to run on. And that's not a mistake, it's on purpose. You can configure that and you can use specified ports if you want to, but maybe your production system needs to assign them for you. Or maybe you routinely use different ports in dev than you do in production. We're trying to encourage you to do more portable things and more flexible things so that you know your application is going to work the first time that you run in production. So to that end, let's do something, let's show off something else that we can do. And I'm going to massage these windows a little bit so that my beautiful face is not covering up my command prompt. There we go. So I'm going to do TIE run -docker, which I guess is going to be just shocking. So can we just run these in Docker? Just is one of my favorite software words. Why don't you just do that? Can we just run these in Docker? And you can see there's lots of Docker things that are happening here. Let's take a look. Appears we can just run these in Docker. So instead of our projects now, we used to see projects here. Now we see containers and we see a base image. Let's give it a try. So that's our back end. And that's our front end. And with our front end, we've got a different listening IP, and we've got a different host name, and we've got a different listening IP and a different host name for our back end. Let's check out one more thing. Docker PS, which if you're a Docker head, not a Docker head, list running containers like PSAX, but for Docker. And you can see that we've got container IDs, images, .NET front-end DLL, .NET back-end DLL. That's our code. So my hypothesis here, these container IDs, this one's 1068 this one's D366. They show up here because inside the container, that's what the operating system says the hostname is. So inside the container, the operating system says the hostname is this. We're reporting that in our code, and it's flowing all the way out. Now, I would remind you that we don't have any Docker files. We haven't done anything to do Docker here. We just ran stuff in Docker, which I think is pretty neat. And we don't lose the ability to do things like see logs because we're running in Docker. And you can see some of those environment variables there. One more little trick here that I think is kind of cool. We'll shut this down. I'm going to do a tie run again and show off one more little thing. Dashboard, by the way, is a Blazor server application. So you see the overlay of gray telling you the process has gone away is a hallmark of a Blazor server application that when something shuts down, we shut down a lot. One of the big enhancements that we're working on, and I'll come back to this again in the future because I think it's pretty important, we're working on a watch mode for tie so that you can do a tie run and leave 15 services running and then iterate on one of them sort of while you're going and not have to shut down everything. So let me get this window and I'm going to shrink this down. So if I click on the name of a service, what it's going to take me to is the metrics dashboard. And this is effectively .NET Counters. If you've seen .NET Counters, a little diagnostic command line tool to read performance counter-like things. This is .NET Counters in a web UI. So it's not a mistake that we're using or not an accident that we're using Blazor server. You can see we've got 2 total requests. Let's do some more requests and just prove that this is really happening. So you can see our number of total requests and active requests per second is going up as I spam the refresh button. So we're getting real counters. It's really happening. This is all really happening to us. So let's try something else. So we're able to write an app that easily runs locally, just sort of easily solve service discovery and communication locally. What if we want, and we could do the same thing in Docker because we've written our app in a way that's flexible about where it's running. Can we run it in Kubernetes? I'm going to check one thing because I think I failed to clean up after myself, which is a sin. Let me just pretend that this is not happening. And I will clean up after myself, and then we'll get on with this. Okay, you can stop pretending that that didn't happen. All right, so let's see, can we run this in Kubernetes? I'm going to do a tie deploy -i, and -i is for interactive. The reason being that I'm going to push this to a real Kubernetes cluster running in Azure. So I need a container registry to push the images to. I'm going to use my Docker Hub. If you have Docker on your machine, I'm going to guess that you already have a Docker account. I think they require you to have one. It's a good little sort of scratchpad place to push images and things that you are experimenting with or that don't have anything sensitive in them. But this could work with any container registry that Docker can use. We effectively just piggyback on top of Docker. So breaking this down for each service, so I entered the container registry. For each service, I compiled the service, I published the project, I built a Docker image, I pushed the Docker image, and I generated manifests. And I've now got this running in Kubernetes. So kubectl get pods is like list the things that are running there. And then by default, things that are in Kubernetes are not going to be accessible to the internet. So if I want to talk to it, I'm going to have to do a port forward. So I'll port forward the front end. And then this syntax is local port to remote port. I happen to know that it's going to be listening on port 80 because that's like the most sensible thing. So that's what we do by default. So local 5000 is now going to 80 in the cloud. And you can see I've got different listening IPs, different host names, and so on. This front end with a horrible thing after it, this back end with a horrible thing after it. These are the names of our pods. So inside the container, inside the pod, that's what the operating system says the host name is, and that's what we're repeating. And these two services are able to communicate with each other in the cloud in Kubernetes without us having to really learn anything about Kubernetes, without us having to hard code anything. and we're able to deploy them without us writing any YAML. So there's actually no YAML anywhere in here. There's no manifests or Docker files or arcane anything that had to be learned or had to be customized. So I think that's pretty cool. I'm going to go ahead and clean this up. Tie undeploy is how you, which I've seen earlier, but you all forgot about. Tie undeploy is how you remove something. Basically, we tag the Kubernetes objects in a way that we can associate them with the application so that we can easily just sort of tear it all down. So whatever we publish, we can also unpublish. So I think that's pretty cool. Let's talk a little bit, let's wrap up a little bit about how this works, right? And let's think about like what goes into a Docker file or what goes into a Kubernetes manifest. So typically what goes into a Docker file is like, well, the base image, right? Where are you starting from? And your base image is usually going to be something like the ASP.NET Core base image version 3.1 or ASP.NET Core version 2.1 or .NET Core version 3.1 or 2.1 if it's a worker, or 5.0, hopefully 5.0. So like, could we guess? Like, could we figure it out? And the answer is yeah, we can figure it out. Docker files for the most part are boilerplate in the common case for .NET because .NET has a rich project system. So we can look at this, we can write tools that look at this and say, oh, this is a web project. We can write tools that look at this and say, oh, this is a 3.1 application. So if you think about like the Docker tools in Visual Studio, the Docker tools in Visual Studio can generate a templated Docker file for you. The next evolution of generating a file is to make the file go away completely. On the side of Kubernetes, I'm not going to assume that everybody here knows Kubernetes, but effectively what goes into a Kubernetes manifest is what port am I listening on, what image am I running, things like that. Just another layer higher than what goes into a Docker image. And the truth is that most of the time those are boilerplate. Not all the time, but most of the time they're boilerplate. So we can generate what you would want for the common case, just sort of trivially, and without making too many assumptions. And we actually haven't had too many feature requests from people to try and add those things. So again, because we're building a .NET focused tool and we know about .NET and .NET has a rich project system, we can sort of easily accelerate all these things for you and you can use them without having to care about them or know about them working. Of course, we do have options for things like using your own Docker file or customizing how that works, customizing the base image. We've had a couple contributions on that from community people, which has been awesome. And like we do have those things, but the point is care about them when you need to care about them. Don't care about them for the super common cases. I talk to a lot of people who say things to me like, well, nobody really knows how to use Docker here. We know how to use the command line, but we don't really know how to write Docker files. And so the way that we use Docker is somebody who doesn't work here anymore wrote a Docker file a year ago and we've copy pasted it into 100 different repos, right? You don't really want to end up there, right? So you can choose to invest. We're sort of on the line of like, well, don't write something down if it doesn't have any meaning. And most of the time for .NET projects, a Docker file doesn't have a ton of meaning, so don't write it down. So one thing, this is admittedly a very simple, very fake kind of demo, right? Because we don't have any data stores or any external dependencies. It's just your code. And like, how many really truly useful applications out there have been written with just your code? Usually you're going to have something more sophisticated or some data stores and things to talk to. And Ty can do that too. I wouldn't bring it up if we couldn't, it'd be embarrassing. So let's take a look at a more reasonable, bigger project. So I've got 3 .NET projects here, and they're in a .NET solution. And this is a sample that I think Docker produced a long time ago. And it is a voting application where you can settle the eternal question of which is best, cats and dogs. And our architecture here, I'll just run through it. There's a voting application, which is I think a Razor Pages application, where it's going to put votes, it's going to take your vote and put it in Redis. And then there's a worker that's going to listen to that Redis instance and it's going to process your votes and put them in a Postgres database. And then there's a results page that's going to display the aggregate number of votes so that we can really get to the bottom of this important question. So we've got Redis and we've got Postgres here and we've got our lovely 3 .NET projects. So let's go ahead and do a tie run and see what happens. So I'll bring up the dashboard again, close some of these. I always end up with this like graveyard of tabs when I do these demos. So something seems off right away, right? We've gotten up to 20 restarts of the voting project, and you can see there's an error. I lovingly crafted this error message: need a connection string for PostgreSQL. The reason why this is failing is that we haven't told anybody how to configure where to get a PostgreSQL instance. We need to run one, but we don't have one. So that's obviously a problem. So if you were living this life today, what would you do? Well, you would install Postgres on your machine and run it, right? Or you would have a staging instance in the cloud and you would copy a connection string and put it in user secrets. Or you might run, if you're pretty savvy, you might run Postgres in a container, but now you're orchestrating external tools. So I need to remember to Docker run my Postgres before I launch my application. You might build some tooling or some scripts around that. Well, it's no surprise that like Ty can manage this for you too, because it's one of the most common things that we have to deal with as service developers is where do my data stores come from and how do I manage their lifetimes? So let's do a tie init. Tie init is a command that is going to just like scaffold out for you a configuration file. And tie does have a configuration file. The reason being that it's not needed for cases like what we saw before, but it's really helpful when your app goes beyond like one or two projects or one or two dependencies. And it's needed for dependencies in general. So you shouldn't be too scared about it because it's too scary. Tie init will, by the way, tie init will scaffold for you what we would generate by default. So this is effectively what tie sees by default if you just give us a solution file or a directory. We do have a schema and we do have schema validation, and there is a bug with it. And the bug has been fixed, but not published out to the version of the schema that I'm using. So I am aware of these little squiggles. They're here to help. And there is some completion and things like that for this file as well. But you shouldn't be too scared about this because it's not as complicated as something like a Helm chart if you've seen those. So going back to what we were doing, we were going to add Postgres and Redis here. So let's go ahead and do that. So here's my Redis. I've just got snippets so you don't have to watch me remember this. And let's talk through this. So I'm adding a service to my list of services called Redis. We're introducing some of the concepts here, right? All your projects are services. Now we have a service that comes from an image. And this is just the Docker image. So this is just the name of the Docker image. Yeah, Redis. And then something else that's cool that's going on here is this binding section. So the way that Ty thinks about bindings and the way that Ty thinks about composition is that you have a list of services. Services have what we call bindings. And bindings are like, here's what I have, right? So if you're Redis, you're saying, here's what I have. I have port 6379 where I'm going to be listening for TCP. And I also have a connection string that people should use if they want to connect to me. And the way to sort of think about the difference between like a URI and a connection string is URIs are always URIs. They always have a port or an optional port, a protocol, and a like host name. Whereas connection strings are just text. So like your database has a password. It's probably not a URI, right? Your Redis connection string might have a password. In this case, it doesn't because we haven't configured one, but it might just be arbitrary key value pairs. It's arbitrary text, right? So the fact that we've declared Redis as part of this application, and the fact that we've declared a binding with a connection string as part of this application means that inside my voting application, I can call configuration.getConnectionString. Now this is a built-in, in-the-box ASP.NET Core method or Microsoft Extensions configuration method. We're actually using the same configuration or the same conventions around connection strings that you would get today if you scaffolded an ASP.NET Core website with a SQL database. So it's not actually different than some of the things you're doing today. We're just automating it for you. And then the way that this works is we're using like text substitution in here to substitute in the port and the host name that Redis is running on. The reason why we recommend doing this, there's a long doc that I wrote about it that's amazing and you should read. But the reason why we do stuff like this, like instead of hard coding localhost, is you can't use localhost inside of Docker to refer to something else inside of another Docker container. So the actual connection string for Redis depends on who's asking, which is an incredibly subtle thing to understand. But for now, just say, you know what, we don't like hard coding, we're not going to hard code. The other thing that's going on here is this Postgres container. So when we initialize this Postgres container, we need to tell Postgres, it's going to create a user for you by default called Postgres, and we need to tell it what password to use for that user. And we can actually use the same sort of like string substitution to say, like, let's not repeat ourselves with that password. So I'm going to both set it as an environment variable for the container and feed it in here as my password. So I've now got Postgres and Redis as part of this sort of service topology, and I'll go ahead and run this. And again, when we do this, all of the services that are part of this application are all going to be offered the connection strings for both of these things through environment variables. So we take the approach by default of assuming that everything's in a Thai YAML are like buds with each other, like they're friends. You can control the visibility of these things if you want to. You can be explicit about the dependencies if you want to. We don't do it by default just because it's complicated. And maybe you don't want or need that level of complication in your life. I know I don't. So we've got our services running, we've got our 2 containers, and we've got our 3 projects. If we go ahead and look at the Redis service, you can see there's log messages here from Redis, and we can see the same for Postgres, except my face is in the way. So we've got everything working here, and let's go ahead and give this application a try. So the first thing I'm going to do is go to my voting application, and I'm going to vote for dogs, of course, because I'm a dog person. And then I'm going to go to the results screen, and hopefully this should work. So we can see we've got 1 vote for dogs. That's pretty cool. You can actually change your vote if you're having a really hard time deciding. I'm only doing it because of a demo. I changed it, and it's cats. Now I can change it back, and it goes back to dogs. So this is all kind of working as you'd expect. If we go to the dashboard here, we can see some log messages from our worker. Our worker is listening on a queue in Redis. It says, got a new vote from Redis. It's identifying me as a user via my session, and then writing the results to Postgres. And then it sort of broadcasts to the results service and says, hey, by the way, the results have changed, and that's how that all comes together. So that's kind of neat. We can see how Thai can manage dependencies and how Thai can get external dependencies working, things like that. Let's think about how we can get this to Kubernetes, because we've now got Redis and we've now got Postgres and things like that. And so it's one thing to deploy your code. It's another thing to say, I'm going to run Postgres or I'm going to run Redis for you in Kubernetes, because that's kind of complicated. And so we don't actually, Thai has support for deploying some containers. If it's a container that you built from source, so let's say you had the source code and you told us to build a container for you, we have support for deploying that, but we don't, by default, sort of by convention, we don't deploy containers for things that you depend on as pre-built images, if that makes sense. The reason being that it's probably not something you actually want to do. Like in my case, like it could be helpful for a demo to deploy Postgres directly to Kubernetes, but like I'm not actually going to go to production that way because I don't really know how to run Postgres in production on Kubernetes. What I would opt for is something like a hosted Azure service or a hosted AWS service if you like AWS. Hosted services are probably a simpler way to go, and so we're kind of optimized for that right now. So when I do a Thai deploy, I'm doing an interactive deploy again, I've put in my username. It's asking me for a connection string for Redis, because the assumption is Redis lives somewhere outside of the cluster. And that's pretty cool. So I've actually got a connection string for Redis. I need to bring up another window, sorry. You will, by the way, I have a presentations repo where I put all of my presentation content for NDC as well as for other things. So you will be able to see all my presentation materials later. They're not super up to date yet. So here's my This will not get checked in, by the way, in case you're wondering, and I will be deleting these databases. But here's my very secure storage for my connection string. So I've put in my Redis connection string, come back to my did I do that wrong? No, I did it right. Okay. Let's get my Redis connection string. Here's my Redis connection string. Cool. So I'm just going to let that scroll. Let this deploy and not leave it up on the screen for too long, in case people feel like being spicy. But I know y'all are mature people. So there, we've done a deployment. It took 2 minutes because I was talking over it, but we've deployed all 3 of our applications, and we've taken the configuration information about Redis and Postgres and put that in Kubernetes secrets. So if I do a kubectl get pods, you can see my 3 pods are running. If I do a kubectl get secret, you can see that I've got a secret for Postgres and a secret for Redis. So let's test this out. And kubectl port forward service. I think it's called vote. Yeah, it's called vote, 5,000 to 80. Hopefully this works. I was having a little bit of trouble with the Redis one last night. Let's see, I'll vote for dogs, and then we have to come back here and let's do the same port forward, but let's do it for results. Okay, that's up, refresh, cancel, that's not what I want. Yeah, so you can see my vote, and there's some existing votes here because this is a long-lived Postgres that I've left running. So we've got some votes here. Everything seems to be going okay. The other thing that I can do is I can do kubectl logs, and let's look at the logs for our worker and make sure that that's all going okay. So yeah, you can see we got the vote, we wrote it to Postgres, other clients updated. That's pretty cool. That's working pretty well. One of the other things that I might want to do here that's kind of interesting is the port forwarding aspect of this has just got me like super fatigued, right? Like it's kind of repetitive and slow and lame. Like I want to expose the voting service to be publicly accessible so that people can party on it and tell me what they really think about cats versus dogs, right? We've talked a little bit about making production like, making development like production. Let's see if we can leverage that. Where did it go? I don't know. I nuked my VS Code. I nuked the VS Code that I wanted. Let's go ahead and do that. So one of the things that I would use if I'm doing Kubernetes is I would create something called an ingress. We've mentioned before that services are internal by default in Kubernetes. If I wanted to expose something to the public, what I would typically do is have an IP address associated with my cluster. I'd have a bunch of DNS records pointing at that IP address, and then I'd have something like an Nginx proxy running there that's feeding traffic to the different services. Well, I normally wouldn't be able to do that sort of thing in my local development, but with Thai, I can. So I can actually add an ingress here to my thai.yaml, and then I'll come over here and I'll do Thai run. And this is actually going to spin up a local proxy. It's not Nginx in our case, by the way. It's some of the guts of YARP, but it is Nginx when we deploy it. So in my list of services, you can see that I've actually got an ingress. So I've configured this ingress to listen on port 8080 and forward all traffic to the voting service. Now the listening port is basically just for local development. Probably should be renamed to like local development port or something. But the idea with this is that you want to be able to test that your ingress is configured correctly. So you can see I got to the voting service, which is what I wanted. You want to be able to test and interact with your ingress in local development, because if you're doing more complicated things like path-based routing, which this does support, you want to be able to test that. You want to be able to make that part of your development workflow. And there aren't a lot of tools out there that can do that. So we felt like that was pretty important. So let's go ahead and deploy this to Kubernetes. Now, since I'm deploying something that's already running, you'll notice that this time it's not going to prompt me for any of those connection strings or configuration data. It is going to prompt me for my registry. It's not going to prompt me for any of that info because it's already got that saved. So it creates those Kubernetes secrets and backs them. And you can see right here, found existing secret, binding production, Redis secret, so on. So it's going to back those connection strings with a Kubernetes secret. And then the next time we deploy, it's going to use that same thing. Now, in order to sort of save time here, I have pre-deployed an ingress controller. So if we do kubectl get pods A, can see that there's an ingress nginx namespace with some pods running in it or one running in it. So I have already deployed nginx. Ty can do that for you. I'm not doing it because it takes about 45 seconds for it to start. There is a tutorial for ingress that sort of explains how this stuff works and walks you through all the concepts and really gives a good explanation of it if you're curious about it. But in order to save your time, I've not done that. So the way that I would get that ingress, we're going to do a kubectl get service. I need to do -a for all. And we can see that I've got this IP address. So this IP address, 52.143.84.28. Let's go to it. I can cast my vote. And I would invite all of y'all to go 52.143.84.28. Somebody wants to paste that in the chat for me. You feel free to go hit that and express yourself. And I'm going to port forward the voting service, the results service, and we can see some of the votes coming in, hopefully. So this would be localhost 5000. So we've got 7 for dogs. So I know some of you are doing it because I can see that this is higher. The cat people are taking over, and the battle is joined. I don't know why it chose these terrible colors. This is really brown and light green. It's terrible. So we've created an ingress. We've made something publicly exposed to the internet. We've shown that we can use containers and dependencies for local development. And we can deploy an app with ingress to the cluster and actually see something public. So we're starting to aim towards doing a fairly complete end-to-end here. So I'm going to go ahead and I'll go ahead and leave that up because I don't think I'm using Kubernetes for anything else today. So let me jump back to my slides and we'll talk a little bit more. So what we saw a multi-project, multi-service oriented development environment. Where you can work on more than one at a time. We saw some really simple patterns around service discovery and how you identify and manage dependencies. We saw using dependencies in Docker and then like really easily putting your own stuff in Docker or putting your own stuff in Kubernetes. Those are some of the basic things that Ty can do for you. I want to shift gears a little bit and talk about diagnostics because diagnostics is a topic that's very near and dear to my heart. Basically, the problem is the more services you have, the more problems you have. I like to say that what used to be a method call is now an HTTP request or a message queue message, right? So you're used to something failing and seeing a call stack, and now something fails in another service at some point in the future, or maybe it doesn't get to the other service, which is the worst feeling. You send an HTTP request and it seems like it's a success and it fails in some other boundary. So we need good diagnostics features for cloud native applications. Otherwise, we're just sort of blind. And the way that I sort of think about these topics is broken into 3 categories. There's logs. How do we combine all the logs that you have and make it easy for you to query across them? There's metrics. How do we look at what's going on your computers and what's going on inside your application? And then there's distributed tracing, which is how do we stitch together events and transactions and communication across different parts of your application that are not part of the same code base or even on the same machine. So to that end, I've got an app that we're going to use as a sample for diagnostics. We're not going to spend a lot of time talking through the app or the code or anything like that. If you've done the Blazor workshop, which I believe the Blazor workshop has been taught at this conference by some friends of mine, this is basically a microservices version of the Blazor workshop using heavy use of gRPC. So I'll share the link for that source code later, and you can check that out if you're interested. And we're going to talk about some diagnostics functionality with that and the sort of tie angle to this. So let's go back to some demos. And I'm going to, let's do this. I've got another repo here. I'm going to bring up VS Code, and then I'm going to immediately do a tie run, and I'll start talking over this while that's starting up. So there's a lot of projects here. Reason why there's a lot of projects is because the way the Blazor workshop is taught, we teach you to create projects for Blazor. So don't worry about that. But let's look at the tie.yaml. So the tie.yaml is kind of interesting because we've got an ingress here. We've got our services. We've got 3 databases. My friend Glenn helped me put this together for an earlier demo. We've got 3 databases. In this case, we're using SQL Server. And these are custom images that Glenn built, but they're based on SQL Server. And we've got a Redis here. So there are 3 databases, a Redis, 5 projects, five like web apps, an ingress, and then these extensions. So the extensions are kind of neat. We've got an extension for Zipkin and an extension for Elastic or for Elastic Stack, formerly known as ELK. Zipkin is a fairly popular and well-known distributed tracing database, distributed tracing dashboard. Jaeger is another one which we don't have direct support for, but we do have Zipkin, and we could add Jaeger at some point. Elastic Stack is a popular like log search aggregation thing built on Elasticsearch and Kibana. So the reason why I've been explaining all this is a massive amount of stuff to start up. In particular, Elasticsearch takes a very long time to start up, and these SQL servers use kind of a massive amount of resources. But true to doing microservices, each service has its own database, which is why there's so many. So I think we've kind of got everything going here. We'll check in on Elastic before we do anything and make sure that that's working. So my dashboard is starting and it's being slow. Running WebEx and all this stuff together. I've got a new MacBook and it's still kind of a lot. Let's check in on Elastic and make sure that that's working. Okay, so we are working here. Great. So let's run through the app and just do something. So I'll go ahead and go to our ingress. So we're loading up the Blazing Pizza app. I'm already signed in because authentication is fake in this version of the demo. And let's go ahead and let's put together a pizza. Now it is like 9:30 where I am. So I think a most appropriate pizza for morning is probably a classic pepperoni, extra large with fresh baked scones because this is breakfast time. So let's go ahead. I'm going to move my face. Let's go ahead and order that. It's in British. This is all the currency and everything here is in British because this is a London-based pizzeria, but they do deliver internationally. So I would love to get notifications, which won't work because I'm in do not disturb mode, and I'm going to very carefully enter my my contact information here for the delivery. They do contactless delivery, which is great. They send you a browser notification and just leave the pizza on the steps. Then you come out and get it. So I'm not actually here. I'm in Seattle, by the way. I'm not at the House of Parliament in London. But anyway, I've placed my pizza order and it's communicating with these different services. We've got an order service. We've got a delivery service. We've got a toppings or sort of inventory service, which is where that pizza info comes from. And then my pizza goes out for delivery and it's on its way via drone from London to my location. So we said that this was about diagnostics. Let's diagnose some diagnostics. So I'll open up Zipkin now. And Zipkin, I mentioned, is a distributed tracing dashboard. And so if I do a search here, I do this search here, you see a bunch of traces. And you should think about traces in Zipkin as like, this is an end-to-end of a request. This is a request that came in and everything else that request did. So I'll pick this one, which was, I think, getting the like order status. So a request, let's talk through this. A request came in to the front end, and then the front end made a gRPC call to the order service. So this is a tracing data created by HTTP client. This is tracing data created by ASP.NET Core. This is tracing data created by HTTP client. So you can see that it's front end, and it's got a URL of another service, and that's a very gRPC looking URL if you haven't looked at gRPC before. And then it goes to the order service. This is created by ASP.NET Core. The order service did something and returned some data. The front end service then, after doing that, because this is a timeline view, said, okay, let's contact the delivery service, and made a call to the delivery service, and sort of the same thing happened. So you can see the end-to-end process of servicing this request. And you could imagine that this would get better over time. Like there are ways to plug in Redis to this, which I haven't done in the example, but you could also imagine a way to plug in SQL Server to this. So you could see my SQL Server query show up here as well, which would be really cool. And that's sort of what distributed tracing does for you. So the next thing I'll do is I'm going to take this trace ID, and the trace ID you can think of as sort of the identifier for the full end-to-end request. Now, ASP.NET Core and HTTP client have code built in that flow those things across requests for you. So you don't have to do this sort of like manual propagation of those things, manual management of headers. Now, this is my Elastic dashboard in Kibana, and this has collected all of the logs of everything. So I can now do queries across all the logs of everything that I have. And it remembers what I like to do last time, which is I want the message, I want the trace ID, and I want the application that was involved. And then let's go ahead, and I'm going to do a filter. I don't know what filter by type is. Oh, this is the one I want. I'm going to do a filter, and I'm going to filter on the trace ID. So I grab that trace ID from my Zipkin, and I'm going to save it here. And hopefully I chose a good one. And you can see I've got log messages here. I've got a consistent view of all the log messages across the front end, the order service, the front end, the order service. And I don't know why I don't have the delivery service here. I kind of expect that, but I don't see it. I have seen issues with this in the local configuration where it seems like events and logs are being dropped. And it might be due to just slow. I'm not totally sure because it's a kind of a crush to run all these things on my machine, especially Elastic. So anyway, sort of unpacking what we've seen here, you can have a request that failed. You can get the trace ID. You can see where in the system it failed. You can take that trace ID back here, and you can see all the log messages across all the services that participated in that transaction and have this nice sort of query dashboard. So if you've ever wondered about structured logging, and why ASP.NET logging sort of is the way it is with key value pairs instead of a string.format, well, it's this, right? All these fields are searchable. So we get the name of the controller action that was being executed. We get the amount of time taken in the request and a whole bunch of other information. This came from MVC. We had a whole bunch of other information here, and this is all queryable by systems like this. And they're really powerful when you combine distributed tracing with logging into one big happy thing. Now, we haven't talked about how this works, and I think that that's probably the best part here. So I've got these two extensions here, which is probably not surprising that Ty is starting and running these things for you when you put them as an extensions. But the other thing that this is doing is it's wiring up our collector to send the data to these things. So we use something in .NET called Event Pipe, which is pretty new. I think it was new in 3.0. And it's what powers tools like .NET Counters, and it's what powers the Ty dashboard. So if you've wondered about how the log collection works for the Ty dashboard or how the metrics collection works for the Ty dashboard, any .NET process, you can effectively attach to it and get a stream of diagnostics information. That stream of diagnostics information includes all of this and all of this if you know how to ask for it and you know how to put it together. So Ty can, without any changes to your application, without any SDKs or configuration that sits inside your app, we can attach to your process, we can get all that information, and we can export it for you so that you don't have to do it. We can do the same thing with metrics. We haven't implemented that yet. There's probably some big gaps to fill around metrics because the metrics collection packages that people have written for metrics collection for like Prometheus are very, very good. So we have some gaps to fill there, which is why we're not talking about metrics too. So that's kind of that in a nutshell. I've got a couple slides that sort of unpack this in a little bit more detail. I'll get my face out of the way. Just, I don't know, there's got to be some physical law that describes how, oh, I know what I need to do. I need to shut this down because this is using a huge amount of memory. There's got to be some physical law about how your face is always in the way on one of these calls of the button you need. So um, when we do this in production, we can deploy to Kubernetes and we can do the same thing. What we actually do in Kubernetes, and I'm not going to show it today just because of time, is we deploy what's called a sidecar in your pods. So we can run our collector in a separate process next to your application, and then we can forward all that data, or we can exfiltrate all that data for you. So you don't have to put any code in your application, or you don't have to configure anything in your application to get these nice features. So that's kind of the end-to-end of where we are with Thai. I think we're kind of about at time. I haven't seen anybody really like having a lot of questions or anything like that. But if you've got questions, I'd be happy to answer them. I'm going to quickly run through some of my own Q&A because I've answered many questions about Thai in the past. And so I've chosen the good ones to kind of snipe you guys. So what does it mean that Thai is an experiment? It means that we have an uncertain future for what we're building and what we're doing here. We see this as a sort of two-way collaboration. And we really don't know, like we really don't have a plan yet as far as what the future is of what we're doing with Thai. It might be the case that all the technology and all the investments in Thai get turned into like other things. You could imagine that Docker building functionality getting just baked into the SDK. You could imagine the multi-launch, multi-debug dashboard kind of functionality baking into VS Code or Visual Studio. So we don't know the ultimate destination. We're just sort of trying to learn as much as we can about what people really want and what they're like, what adds value, what makes your life better. Guillaume asks, adding Thai to an existing project is an easy process. I would say that it's the easiest process because the only thing that Thai really wants in your project is there's one method to read like URLs, right? There's some opinionated use of configuration, but you've already got configuration. I would say that Thai is something you use to automate your process rather than add to your process, unless you're talking about a development process or a like DevOps process, in which case, tell me more. So I would say if you're already doing .NET today, like it's one of the easiest things that you could start using that will probably really give you a boost in terms of your productivity. If you don't think that it helps you, I'm really interested to know what you're doing that makes you so satisfied with your development workflow. So who's this for? Thai's for developers. We do some publishing and we do some Kubernetes stuff, but Thai is a developer-oriented, developer-focused tool. I think for a lot of people, they look at the Kubernetes functionality and they say, wow, I didn't know I could do Kubernetes. That's kind of cool. And they move on with their life, or they use it as like a learning tool for Kubernetes. I think for a lot of people on the other end that are very experienced with DevOps and Kubernetes would say, I've already solved these problems. It doesn't add a lot to me. I think that the deployment and Kubernetes aspects of Thai is the part that's like really experimental. So we're looking for feedback there, to be honest. Like we're looking for ideas and we're looking for feedback about, I would use this, I wouldn't use this, and here's why, to help shape future direction. I think there's a spectrum that people fall on as far as their organizational maturity with DevOps and their organizational maturity with those practices. So you can sort of think of what you've seen today as like right-click publish, but for Kubernetes, which there aren't a lot of examples of in the industry. We do have the idea that something like Thai could be part of a GitOps workflow, but we haven't really done the work to prove that out yet. Thai does play with things like versioning. So if you have a versioning scheme set up for your projects already that's MS Build based, Thai can already work with that. Because my stuff was demos, everything was 1.0, but Thai can already work with those kinds of things. It only does Kubernetes. Can it do other things? So I really like the idea that we would be able to do other things. Kubernetes is where we started, I think, for a variety of reasons, namely that we wanted to expose .NET developers to Kubernetes. The more we've talked to .NET developers about Kubernetes, the more we found pockets of people who are being very successful very quietly, which has been interesting for us to talk to and to learn from. Um, you might have access to Kubernetes, and if you don't, you can easily get access. You can run it locally with Minikube or something like that. And so it's a good way to get your feet wet in this technology if you're new to it. And then lastly, Kubernetes is powerful enough for us to do really powerful stuff like diagnostic sidecars and ingresses and things. I think we're interested in ideas about where else we could do publishing and deployment, but without turning Tye into an Azure specific tool specifically, despite the fact that I now work on Azure. Why did we build this? That's actually one of the most favorite questions that a lot of people have. I think we're looking in the microservices and backend development space and saying, what can we add here? And our frameworks are fairly mature. We hear success stories and happy stories from users every day about how they're thrilled with the platform or they're thrilled with the latest upgrade. And the truth is, like, we can't just keep churning stuff. We can't just keep changing stuff. Um, there's a cooldown period after doing like a dramatic change to something, and so we can't just keep tweaking and changing and modifying and updating. It becomes a treadmill after a while. So we're looking for other ways to add value. Turns out very few people are happy with their dev productivity for microservices. There aren't a lot of tools that solve it really well. So some stuff that's unique about Tye is, first of all, the philosophy of being a tool that goes through the existing process with you. You start from the moment you decide to write code, and Tye continues to live with you until you've got something fully automated with the CI/CD system. That's the sort of vision for it. There aren't a lot of tools that try to solve that. Most tools try to focus on doing one thing well. We're trying to do everything pretty well. And we're also think that there's a lot of value out of building something .NET focused for .NET developers. That is to say, that is not to say that everything has to be a .NET project. We immediately heard from a lot of people when we started working on Tye that they wanted support for non-.NET projects, because everybody out there has got like one Angular app and 5 ASP.NET backends. So we do support building and publishing sort of arbitrary Docker images as well as .NET projects from Tye, which is a fairly recent addition. So that's the end. You can find me on Twitter if you want. These materials will be uploaded to my presentations repo at some point. And thanks everybody for your attention. I'll probably be hanging around. I'll probably be hanging around the conference for a couple more minutes if people have that they want to ask or things that they want to say. But other than that, thanks for your attention and have a great rest of the conference.